Welcome to video 3 for this unit on functions. In this video, we're going to focus on the graphs of functions. The graph of the function can give us useful information about the quantities in a situation. Some points and features of a graph are particularly informative, so we pay closer attention to them. Let's look at the graph of function h, which gives the height in meters of a ball t seconds after it is tossed up in the air. The point 0, 20 is the vertical intercept of the graph. This point tells us that the initial height of the ball is 20 meters, because when t is 0, the height of h of t is 20. The point 1, 25 is the highest point on the graph, so it is a maximum of the graph. The value 25 is also the maximum value of the function h. It tells us that the highest point the ball reaches is 25 feet, and that this happens 1 second after the ball is tossed. A maximum of a function is a value of the function that is greater than or equal to all the other values. The maximum of the graph of the function is the corresponding highest point on the graph. The point 3.2, 0 is a horizontal intercept of the graph, a point where the graph intersects the horizontal axis. This point tells us that the ball hits the ground 3.2 seconds after being tossed up. So the height of the ball is 0 when t is 3.2, which we can write as h of 3.2 equals 0. Because h cannot have any lower value, 0 is also the minimum value of the function. This point is also the lowest point on the graph, so it represents a minimum of the graph. A minimum of a function is a value of the function that is less than or equal to all the other values. The minimum of the graph of the function is the corresponding lowest point on the graph. Now let's consider the overall shape of this graph as we follow it from left to right. A function is increasing if its outputs get larger as the inputs get larger, resulting in an upward sloping graph as you move from left to right. A function can also be increasing just for a restricted range of inputs. For example, function h is increasing when the time is between 0 and 1 seconds, because the graph slopes upward as you move from left to right. A function is decreasing if its outputs get smaller as the inputs get larger, resulting in a downward sloping graph as you move from left to right. A function can also be decreasing just for a restricted range of inputs. For example, function h is decreasing when the time is between 1 and 3.2 seconds, because the graph slopes downward as you move from left to right. Here is a graph of 1 day's temperature as a function of time. The temperature was 35 degrees Fahrenheit at 9 a.m. and 45 degrees Fahrenheit at 2 p.m. An increase of 10 degrees over 5 hours. The increase wasn't constant, however. The temperature rose between 9 a.m. and 10 a.m., stayed steady for an hour, then rose again. On average, how fast was the temperature rising between 9 a.m. and 2 p.m.? Let's calculate the average rate of change and measure the temperature change per hour. We do that by finding the difference in the temperature between 9 a.m. and 2 p.m. and dividing it by the number of hours in that interval. On average, the temperature between 9 a.m. and 2 p.m. increased 2 degrees Fahrenheit per hour. Now let's consider how quickly was the temperature falling between 2 p.m. and 8 p.m. On average, the temperature between 2 p.m. and 8 p.m. dropped by 2.5 degrees per hour. The average rate of change of a function f between inputs a and b is the change in the outputs divided by the change in the inputs. It is the slope of the line joining a, f of a and b, f of b on the graph. Thank you for watching video 3 of 7 for this unit on functions.